is the fact that we have isotopes. And these are elements with the same number of protons, but different number of neutrons. And here is a really common example. This is the carbon that exists in this, and this is the carbon that helps us date fossils and dinosaurs. So this is a lot more common in real life, whereas this is very rare. But we use this isotope for carbon dating, something which we'll not get into this class. So here we'll practice reading. The number of protons is 6. The number of neutrons is 12 minus 6, which is 6 neutrons. Here, number of protons is also 6. But here we have 14 minus 6 is equal to 8 neutrons. In your lab, we talked about cobalt-60, which is a radioisotope that we use for cancer treatment. So cobalt-60 has an atomic symbol of this, where we identify that this is the mass number. So we'll say this is 60. The atomic number is 27. The number of neutrons present, we're going to use the calculation. 60 minus 27 is equal to 33 neutrons. The number of protons, per usual, is just as the atomic number, which is 27. The number of electrons is determined by the charge. I never specified a charge, so you can assume it's 0. So 0 is equal to the number of protons minus the number of electrons. The number of protons is 27 minus a number is equal to 0. The only number that this could possibly be true is 27. So we have that it must be that there are 27 electrons present. Another isotope of cobalt that is more common than this is cobalt. The mass number is instead 59. 59 minus 27 is 32 neutrons. The number of protons should stay the same because an isotope has the same number of protons. And since the charge is 0, we will remember that 27 protons minus 27 electrons is equal to 0 charge, and there is a 0 charge in this atom. Lastly, we might not get to go this far, but I wanted to expose you that there are concepts called ions, which are elements that have the same number of protons, but different number of electrons. So let's practice counting in this example. Here there are 1, 2, 3, 4. There are 4 protons and 1, 2, 3, 4 electrons. And if we practice our charge calculations, we have 4p minus 4e is equal to 0. So this would have 0 charge. Here we have another ion where there are, wait, this is a terrible image. Let me just fix this image. All right, now we have 6 protons and 1, 2, 3, 4 electrons. If we try our calculation, 6p minus 4e, we get 2, a plus 2 charge. So this is a positive ion. We also have this example. We have 1, 2, 3, 4 protons and 1, 2, 3, 4, 5 electrons. And we can do a similar example for charge. 4p minus 5e is equal to negative 1 charge. So this is a negative ion, which we call an anion. And the positive ion is called a cation. So ions are elements with the same number of protons, different number of electrons. Here I'll get to show you fluorine 9. Let's do fluorine 19 minus 1. These two examples. So now we get to practice. So the atomic number is 9. The mass number is 19. The number of neutrons is the mass number minus the proton number, which is equal to 10. So 10 neutrons. The number of protons is the atomic number. Here we identified that the charge is -1. So -1 is equal to 9 protons minus X number of electrons. How many electrons do we need to make this equation true? So in order to make it -1, we need to make sure that there are 10 electrons, so that 9 minus 10 is equal to -1. So there are 10 electrons. For sodium, we identified the atomic number is 11. The mass number is 22. There are 22 minus 11 equals 11 neutrons. There are 11 protons. And we have a +1 charge. So +1 is equal to 11 protons minus a number of electrons. The only number that could make this equation true is 10, because 11 minus 10 is equal to +1. So there must be 10 electrons. When atoms gain electrons, they become negative ions. When atoms lose electrons, they become positive ions.